Hi everybody! So today I wanted to put together a video showing off the large interference figure projectors from Snellius Minerals LLC. There's a previous video on the small interference figure projectors. However, the really cool thing about this is you can scale these techniques up to whatever size crystal you actually have. On the economic side of things, the linear polarizers are really quite cheap, and so the expensive component of all these pieces is not going to be the polariscope we build around our crystal, but the crystal itself. Let's take a look at some of the large interference figure projectors to learn more. Here we have an assortment of the large interference figure projectors, and right now they're being backlit on a white LED light board, something similar to what you might use for tracing. The setup of our large interference figure projectors is the same as the small interference figure projectors, and here's a quick diagram for reference. Here we have a side view of one of the large interference figure projectors, and this consists of a lower polarizer, our crystal sample, and an upper polarizer that's oriented perpendicular to the lower polarizer. We could also include a light diffuser in this setup, however, we'll talk more about the pros and cons of that later. The large interference figure projectors are all held together with different materials. This one happens to be some acrylic sheets held together with a variety of nuts and bolts. You can also see the side of the light board in this view, which is our light source. Back to our backlit view of our large interference figure projectors. There are a variety of ways we can explore the optical properties of our different specimens using this setup. Right now, the colors that we're seeing are either interference colors or a result of the optical activity in quartz. And by shifting our view, we can actually see our interference colors and the optical activity of our quartz shift a bit. As our view changes, what you're effectively seeing is just a small piece of an interference figure for our different minerals, and what we're going to do to see the big picture is bring in a converging lens. We'll start by looking at our sample in the bottom left, which is a slice of watermelon tourmaline, and we bring in our converging lens, and you can see a uniaxial optic axis interference figure. Next, we'll move our converging lens one sample up, and now we get a quartz uniaxial optic axis interference figure with quartz's special bonus power of optical activity. Moving up to our next sample, we get another uniaxial optic axis interference figure. This one is for the mineral corundum. We could continue to do this for all our large interference figure projectors, but there's another way actually to do effectively the same thing. When doing these demonstrations in person, I get people to bring their eye as close to our interference figure projector as possible, but in this case we're going to bring our camera and camera lens close to our samples, and you'll get to see the same thing. Here is our tourmaline. Next up, our quartz sample with optical activity. Here also is a Brazil law twin in our quartz specimen, and a whole bunch more on that can be found in the video Snellius Minerals Quartz Brazil Law Twins. And next up is our corundum specimen again with its nice uniaxial optic axis interference figure. This next specimen is topaz, and this is a biaxial mineral. In this case, the optic axes for our topaz are so far apart, the converging lens is actually pretty necessary for us to see what's going on. You can see one of the optic axes here, and then another optic axis will be in the opposite direction, separated by the 2V angle of our topaz from one another. Check out the Snellius Minerals Topaz Optic Axis video in order to learn more. Last up in this column of specimens is just another much larger corundum sample, so you can see this really works at whatever scale you can get a crystal at. These next two specimens are more about extinction angles and epitaxial overgrowth in lepidolite on muscovite. We're going to kind of let those go for now. Next up is a sample of biaxial muscovite, and we have a nice BXA interference figure in this direction looking through our crystal. And the next specimen is of two pieces of muscovite mica that are oriented to destructively interfere with one another. Once again, the main limit on these techniques is just how large of a crystal you can find, and so here is a larger version of two pieces of muscovite mica destructively interfering. And by bringing in our converging lens, we can get a better idea of the overall interference patterns that are going on here. Next up, I have something a bit different. I was hoping to get some artists interested in the optical mineralogy techniques as well, because I feel like there are some pretty neat things you could do with this. As you can tell from my rendition of a fish, I am not an artist. But you could make patterns and designs using these techniques with sort of different thicknesses of mica plates and or adding on mica plates to destructively or constructively interfere. There's a bunch of history here too. One of the original companies to make oriented crystal sections, the Dr. Stieg and Reuter Company, made similar items using mica plates as well as gypsum plates. These items didn't have linear polarizers integrated into them though, so they were meant to be viewed in a polariscope. This paper too is a great read if you want to learn more about the history of oriented crystal sections, and thank you to Dr. Olaf Mendenbach for sending it my way. Back to our fish. This design was made using different thicknesses of muscovite mica, and then also adding on a plate in the center to interfere destructively, which you can see here with this converging lens. Other areas of this design are just variable thicknesses of muscovite mica. And I think there are lots of ways that you could use these techniques to generate some pretty interesting looking art. Next up, we have a series of sequential quartz slices from the same quartz crystal. These interference patterns provide a variety of information. These are fairly clean and have respectively little Brazil law twinning, and the color that you see in the central circle of our interference figure is a reflection of the optical activity of our quartz, which in turn is dependent on the thickness of each of our quartz slices. And lastly, here's another quartz crystal slice, and this one has all sorts of Brazil law twinning going on. Please do check out the quartz crystal Brazil law twin video if you want to learn more. But if we bring in our converging lens, you'll notice that our interference pattern gets all sorts of shifted, and these are Aries spirals, a very specific type of interference pattern caused by that Brazil law twinning in quartz. So that was the first way to interact with the large interference figure projectors, have them backlit, and then use a converging lens in order to generate an interference figure. The next way to interact with the large interference figure projectors is to look through them. To do this, you want to be looking towards a bright light source and not have too much light behind you, or else you'll start to see reflections off of surfaces instead. We'll start off by taking a look through our quartz slice, and as we bring this large interference figure projector up to our camera, you can see the quartz uniaxial optic axis interference figure superimposed on our view. This viewing setup is similar to the optical ring sights that Polaroid produced during World War II. And if you'd like to learn more, check out the video Snellius Minerals Optical Ring Sight from World War II, or to get the full history, I recommend the book Rings of Fire. And special thank you to Larry Hughes for allowing me to use some of his figures in my other educational video on optic ring sights. Alright, so let's check out some of our other large interference figure projectors using this same viewing style. The optical activity of our quartz makes it fairly unique, but if we have a more generic uniaxial mineral like corundum, we get a pretty standard uniaxial optic axis interference figure. All of the interference figure projectors today are set up with crossed polarizers. However, you can also do some fun things with this with our polarizers parallel to one another or at other interesting angles. Next up is our biaxial topaz set up to be at extinction, and the optic axes here are actually pretty far away from the cleavage plane, so we have to tilt the sample pretty well, but you can see here as the sample tilts, the two different optic axes can be seen. We can do this viewing style with pretty much any of our samples, but for the sake of time, let's check out the large specimen of two oriented muscovite mica samples that are destructively interfering, and you can see this works in a pretty similar fashion to all the other samples we looked at before, and we end up with a pretty cool design. Those are our examples of using the large interference figure projectors similar to an optical ring sight. And we have one more viewing style for our large interference figure projectors, and that's to project interference figures with them. We need to change our lighting and video setup in order to do this. So what we have here is all our specimens, but now I'm in a darkened room and the only illumination source I have is a flashlight. And what we're going to do is simply shine the flashlight through our interference figure projector. Here we have quartz along the optic axis, producing a quartz uniaxial optic axis interference figure. Next up, we have corundum along the optic axis, producing a uniaxial optic axis interference figure. We'll then take a look at biaxial muscovite mica and a BXA interference figure. And here we get into something a bit interesting. If you wanted to project the interference figures even better, you'd add in a light diffuser to these specimens in order to scatter the light more effectively. However, then you wouldn't be able to view through a specimen in an optical ring sight style like we did earlier. And so one of the workarounds for that is just to move the flashlight orientation a bit so you can see different parts of the interference figure a bit better. However, you get a little bit of reflection then too. So there's a trade-off just depending on what you want to do with the large interference figure projector. And lastly, we have our two pieces of muscovite mica oriented to destructively interfere. You can see where we have them interfering and where there's just a single piece of the muscovite mica. Today we investigated the large interference figure projectors. These are fairly simple devices consisting of a custom cut mineral sample sandwiched between two polarizers. And for our examples today, all the polarizers were perpendicular to one another. However, you can also do fun things with polarizers in other orientations. We explored the large interference figure projectors under various lighting conditions. First, we started by looking at the specimen's backlit and then adding in a converging lens. This allows us to generate interference figures for our various specimens. And these interference figures are a product of the structure and symmetry of our crystals. You can generate a similar effect simply by bringing your eye close to the large interference figure projectors, or in this case, our camera and camera lens. My personal favorite is definitely the quartz. Another viewing setup using the large interference figure projectors is to view through them in a style similar to an optical ring sight. In this case, it allows us to superimpose our quartz uniaxial optic axis interference figure onto our view. Our last viewing setup for the large interference figure projectors is to use them to project interference figures. In this case, we want to be in a dim room and shine a flashlight through our specimen. So those are all the different ways we can use the large interference figure projectors. I've got some of the large interference figure projectors for sale at the eBay store Snellius Minerals. However, this is something I imagine that you might want a custom version of. If you have large, clean crystals and are thinking maybe of a different way to display them, or are interested in the optical properties of minerals, these techniques might be suitable for you. So if you have any questions, comments, or any custom requests, feel free to reach out to me at snelliusminerals@gmail.com. Here are the references that I used in the creation of today's video. Thanks again for watching, and have a great day!